Put up my chart like we always do for any type of subnetting. We have our 8 bits, and then we double as we go to the left. These are also our power numbers. 2 to the 0 is 1. 2 to the first is 2. 2 to the second is 4. 2 to the third is 8. 2 to the fourth is 16. 2 to the fifth is 32. 2 to the sixth is 64. And 2 to the seventh is 128. And we learned the last time we were here, if we need bigger numbers, we can extend our chart, right? So 2 to the 8th is 256, and 2 to the 9th is 512, and so on. What we're going to do today is variable length subnet mask. And variable length subnet mask allows us to preserve more IP addresses and have a custom range for all of our requirements. So in order to show that, first I want to do the method that we did yesterday to kind of show how inefficient it is. So yesterday we did it per device. So if I gave you device requirements of 50, 30, 15, and 3, what we would do is we'd take the highest host requirement, in this case it's 50, and we would ask ourselves 2 to what power will give us at least 50 hosts. So you can choose 2 to the 6th. Questions with power number. Okay, so what that 6 tells us is how many zeros we have right-hand side of the line. So here comes those 6 zeros. 1, 2, 3, 4, 5, 6. Draw our line. 7, 8. I only need 8 total bits. That top line is my subnet mask. Then below that line, I would take my starting point for my new network ID, and I should have given you one to start off with. And here it is. I'm giving you the 172.16.1.0 with the /24 network to subnet for these requirements. Okay. So below this line, I take my starting point for my last octet, which is 0, and I put it in binary. That gives me my first network ID. All zeros is just 0. Then I make the right-hand side 1s to get my broadcast. My network ID. Make the right-hand side 1s. Convert this number back. That's going to give me my broadcast. And that number, if you convert it back, is 63. Okay, so I essentially have my pattern, right? And I can just repeat it. So 63 is where I ended. So my new range is going to start at 64. And then I take my 63 and I add it on to 64. And I have 127. Next range starts at 128 through 191. And then 192 through 255. Okay. All of these ranges are going to have the subnet mask of a slash. Here's my 25th and my 26th one. A /26, which is the same as a 22255.192. Questions here so far? Okay. So now my question is, how many devices or hosts can each one of these networks have? And there's a few ways to do that. You can probably look at this first range and think to yourself, okay, I can't use the 0 because that's network ID. I can't use the 63 because that's the broadcast. I would have between 1 and 62 for my devices. So I have 62 possible, right? Another way I could do it is take 2 to the power of how many zeros I have right-hand side. 1, 2, 3, 4, 5, 6. 2 to the 6th is 64. So I subtract 2 off of there. Can't use the first, can't use the last. I'm left with 62 possible hosts per network. Good there? So if I have 62 possible hosts, and in this one I need 50, I'm wasting 12 addresses, right? And if I have 62 possible hosts, and in this network I need 30, I'm wasting 32. And in this network, if I need 15, and I have 62 possible, then I'm wasting 47. And in this network, if I have 3 for my need and I have 62 possible, I'm wasting 59 addresses. So overall, I'm wasting, what is that? And I'm wasting 160 addresses. That's going to edit that out. 150 addresses that I'm wasting, okay? So what we're going to do is we're going to take this same exact scenario and we're going to variable length subnet mask it to give a custom subnet mask and custom range for all of these criteria, and we'll see how many addresses we waste now. So I'm going to make a little note here that we wasted 150. The process for variable length subnet mask is essentially the same, but you cannot find your pattern like we had and just repeat it. Essentially, you have to do a new subnet, a new calculation for every single range. So it takes a little bit more time. But the whole process, like we just drew out here with all our ones and zeros, is kind of the same thing. So variable length subnet mask, you always start with your highest host requirement. You start at the highest and you work your way down. You have to do it that way. You can't start lowest and work highest. Start at the highest and work your way down. So my highest host requirement I have here, and I have in order, is 50. So I ask myself 2 to what power for 50, and we said it's 2 to the 6th. So 2 to the 6th means 6 zeros right hand side. 1, 2, 3, 4, 5, 6. Draw my line, 7, 8. I need 8 total bits. And then I have my other 3 octets there. This becomes my subnet mask. I take my starting point, which is 0, and I put it below the line to give me my network ID. All zeros is just 0. Then I make the right-hand side of the line 1s. And that gives me my broadcast, or the end of the range. And that we came up to be 63. Okay, so this first range for 50 is going to be between 0 and 63. And it's going to have a subnet mask of a /26. Here's 8, 16, 24, 25, and 26 ones. /26. So questions on how we came up with that range? Same thing we just had before, right? Okay, so now with variable length subnet mask, what you do is you tell yourself the next range is going to start at 64, but now I have to stop and recalculate. I have to erase all of this, and now I recalculate it for 30. I ask myself 2 to what power is going to give me at least 30 hosts? 2 to the 5th. That's going to be right on, right? 2 to the 5th. So now I have 5 zeros right-hand side. 1, 2, 3, 4, 5, 6, 7, 8. I need 8 total bits. This is my new subnet mask for that range, which happens to be a /27. 8, 16, 24, 25, 26, 27 ones. Then I take my starting point, which is 64, and I put it underneath this line. So that is my network ID for that second range. Then I make the right-hand side 1s. Convert that number back. 64 plus a 16 plus an 8 plus a 4 plus a 2 plus a 1. That's 64 plus 31. That's 95. So now I have a second range my broadcast. So now I have a second range between 64 and 95, but it has a subnet mask of a /27. Questions there? Yeah.
Where did you get the one coming down for the name? Is that from
right here?
previous?
That's from my new starting point for this range.
Oh. Your starting range is determined by your range you got the first time.
Yes, your starting range is going to be determined by, or your starting point, I should say, is going to be determined by where you left off on the last range. Other questions? So what's my next range going to start with? 96. That's going to be my new starting point, or my new ID, for my next range, which happens to be for 15. So now I ask myself, 2 to what power for 15? 2 to the 5th. So in this case, since it's the same power, I could just repeat my pattern, right? I'm just going to do it the long form. 2 to the 5th, 5 zeros right hand side. 1, 2, 3, 4, 5, 6, 7. Again, I have another /27. I take my new starting point, 96, and I put it underneath this line. There's my new network ID. That's 96 in binary. That was my new starting point for this range. Your starting point should always fit on this left-hand side. You know what I mean? So a 96 wouldn't have a bit over here, because if you remember, the ID has all zeros on the right-hand side, and the broadcast has all ones on the right-hand side. So now what I do to get my broadcast is I make the right-hand side of the line all ones. Convert that number back. Yep, and that is 127. I have everything but that one, so it's 127. So 96 through 127 is for my third range. My fourth range is going to start at 128. Stop and ask myself, 2 to what power for 3? I have to bump up to 2 to the third, yep. I cannot use 2 to the second, because 2 to the second only actually gives me 2 possible addresses. So 2 to the third tells me that I have 3 zeros right-hand side. 1, 2, 3, 4, 5, 6, 7, 8. Okay. And now what I do is I take my new starting point, which is 128, and I put it underneath the line. That's going to give me my network ID. Okay. You have it written out. Then I make the right-hand side of the line ones to give you the broadcast. It's 128 plus a 4 plus a 2 plus a 1. 128 plus 7 is 135. And the subnet mask for this range, here's my 25th, 26th, 27th, 28th, and 29th one. /29. And now I have 136 through 255 that are left over. I can reserve for future use, or I can give that to a different company, an organization, whatever I needed to do. And now let's take a look at how many addresses I'm wasting. Before I wasted 150 doing it per PC. Variable length subnet mask style. Here I have 62 possible. I only need 50. I'm wasting 12. Here I have 30 that I need. 30 possible. Wasting 0. Here I have 15 that I need. 30 possible. Wasting 15. Here I have 3 that I need and 6 possible. I'm wasting 3. So if I add that up, I have a 30 devices total, or addresses, maybe I should say 30 addresses total that I'm wasting compared to the 150. So a lot more efficient doing it variable length subnet mask style. Questions? Yeah?
For 3, what did you use? 2 to the second?
2 to the second doesn't give me enough because I have to subtract 2 off of these numbers. If I had 2 to the second, I would end up with a range of 0 through 3. And I can't use the first one, and I can't use the last one, so I only have 1 and 2 available. So I end up being short. You remember, if you're right on the number, so 64 or 1 less, 63, you have to bump up. Here, if I was at 16 or 15, I would have to bump up. So I always have to subtract 2 off those. Yeah.
Why do you need to subtract?
You subtract the 2 off because of the network ID and because of the broadcast.
Oh.
Questions? Okay, this is what I want to do. I'm going to do one more relatively quickly. And I'm going to have half of you guys come up to the board. I'm going to give you a scenario and see if we can figure it out. And if we have time, I'll have the other half. I'm not going to do that to, embarrass you or try to trick you or fumble you up. I just want to kind of see where everybody's at. If I can see your process and how you're working it out, it gives me some insight on whether we need to spend a few more days on this or 1 more day on it or whatever. If everybody's getting it, then we won't spend a whole lot of time on it next week. But if I see that people are kind of struggling and thinking, what am I supposed to do, then we'll spend some more time on it. So let's do another requirement here. We'll work this one out, and then we'll have you come up to the board and see if you can figure one out. So we've got host requirements of 2, 25, 100, and 15. And I'm going to give you the IP address, 165.234.48.0 with a /24 to use the subnet. So variable length subnet mask style, you always start with the highest host requirement, which is 100, and you ask yourself 2 to what power for 100 hosts? 2 to the 7th. So that 7 tells me 7 zeros right-hand side. Draw my line, and then my 8th bit becomes a 1. Below that, I put my starting point. My starting point for that last octet happens to be 0. So I put that 0 in binary. And that gives me my network ID. To get my ending point or my broadcast, I make the right-hand side 1s. So I have 0 through 127 for that first range. And it's a /25. I'm only borrowing or adding 1 additional bit there. So /25. I have another 8, another 8, and another 8. 16, 24, 25th one. Okay? Next range is going to start with what? 128. It's always 1 more than the last. I stop and ask myself, what's my next highest host requirement? 25. 2 to what power for 25? 2 to the 5th. That 5, or 2 to the 5th, tells me I have 5 zeros right-hand side. 1, 2, 3, 4, 5, 6, 7, 8. So my new subnet mask, I can already tell, is going to be a /27. There's my 25th, my 26th, and my 27th one. Network ID, my new starting point is 128, you guys told me. So I draw out 128 in binary. Then to get the broadcast, I make the right-hand side ones. So I have 128 now plus 31 is 159. Question. What's my next range start with? 160. Yep, one more than the last. So I'm going to start it at 160. What's my next highest host requirement? It's 15. 2 to what power? 2 to the 5th. So I keep my 5 zeros right-hand side. I already have those drawn out. My network ID would be different though. 160 is my new starting point. And a 160 is a 128 and a 32, so there's my 160. Then to get the broadcast, I make the right-hand side ones. So I have 160 plus 31, 191, same subnet mask because I borrowed the same number of bits, 5 and 5. Questions? Okay. Next range is going to start with 192. My next highest host requirements, 2. 2 to what power for 2? Second, yep, 2 to the second. That tells me 2 zeros right-hand side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 8 total bits. My new subnet mask is going to be a /30. 25th, 26th, 27th, 28th, 29th, and 30th one. Whenever you see a host requirement for 2, it's always going to be a /30. Every time. /30. 192 is my new starting point. So I put 192 in binary for my ID. Then I make the right-hand side of that line ones to get my broadcast. So it's 192 plus 2 and a 1. So 192 plus 3 is 195. And that's what always happens with your host requirement of 2, is you end up adding 3 onto your network ID. So I can't use 192 because that's the network. I can't use 195 because that's the broadcast. So I have 193 and 194 that I can use, which is perfect. So if I asked you guys the question, what would be the address of the last usable host out of the third network? 190. So full answer would be 165.234.48.190. Can't use this one because it's the broadcast. And we'll have a subnet mask of a 222.5.224. That's equal to a /27. And if I asked you what is the network ID of the second range, you would tell me 128. And if I said you have a PC that has an IP address of 165.234.48.100, what network is it a part of? The first one, the .0 network. You can do that 2 ways. You can figure out that the .100 is within this range, making it that the network ID, or you can go through that ANDing process, where you AND together the IP address and subnet mask, and that gives you the ID. That's exactly what a router does to figure out network.